All right, so let's just talk a little bit about what happened in our investigation today. So we started trying to find the slope at 1 comma 1, and we found some slopes on the left-hand side of the point and some slopes on the right-hand side of the point. So on the left-hand side, we had 0, 0, and 1, 1, which gave us a slope of 1. And then on the right-hand side, in that same time, we had 1, 1, 2, 4, which gave us a slope of 3. So we can say that 0 is one space away from 1, and 2 is one space away from 1. So I'm going to make up this thing called h, which just tells me how far away I am from the point. So h was 1. Then I got a little bit closer. I zoomed in a little bit more. So I went to 0.5 and 1.5. So now I'm only 0.5 away from 1. And when I talk about all of these distances away, I'm talking about the x value. So where did I go on my x value? The y value comes from the function. So I don't get to pick the y value, remember? The y value depends on the x value. So I got to make a choice of x, and then y was determined. So, yes, so I was 1 away, 0.5 away. Here I was 0.1 away, so I'm at 1.1 and 0.9. I'm at 1.01 and 0.99. Okay, so this tells me how far away I am from 1, 1. So in general, if you have a value h, you could say that your x value comes from 1 minus h, and your x value on the right-hand side comes from 1 plus h. So h tells me how far away I am from the point, 1. And again, I'm talking about how far away I am on the x-axis, the x values, because those are the independent values that I can pick. Then the y value just comes from plugging in whatever I had for x into my function. Okay, now let's talk about how we would find the slope. So say I want to find the slope on the left-hand side lines. I would take my y value here of 1, subtract my y value here, which is whatever I got when I plugged in x. Then I would take my x value here and subtract my x value of 1 minus h. If I were to simplify that, I would get 1 minus f of 1 minus h. And in the denominator, I would change this subtraction to addition. This would become a negative 1. This would become a positive h. And I would be left with h in the denominator. So this would be the slope in general. So I have 1 minus f of 1 minus h over h. Similarly, if it was on the right side, I would have f of 1 plus h minus 1, that's my y's, divided by 1 plus h minus 1, that's x minus x. 1 plus h minus 1 leaves me with f of 1 plus h minus 1 over h. So this is the notation for slope. All right, of when you're trying to find, this is the point 1 comma 1 and a point really close to it. So this is a point really close to it on the left, and this is a point really close to it on the right. What we did in our activity, what the idea is that we zoomed in. So we made h get smaller and smaller and smaller and smaller, and our slopes got closer to the same number. And most of us predicted that if we made h as small as we possibly could, we would wind up with a slope of 2. Now, the thing we have to remember, though, is that here we have h in the denominator. H cannot equal 0, because then we would be dividing by 0. So we can make h really, 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 really small. And even here, it's not even all that small, 0.01. But you saw by zooming in, we're making it smaller and smaller and smaller and smaller. And these two slopes on either side are merging. They're getting closer and closer to 2. But again, we can't totally get there because we can't make h 0. You can think about that in a few ways. You can't divide by 0. Also, if h were 0, this would be 1 comma 1 and 1 comma 1. And you wouldn't really have a slope to find because you would be at the same point.